Today I will prove to you that we are living literally on a flat earth. Now, a globe earth like this one is completely different than a system of a flat earth, but both are round. I'm not saying the earth is not round. I'm saying the earth is a disc. It's round. It is round and flat, but it's not a globe. And what surrounds this round, flat earth is a wall of ice. Captain James Cook, when he discovered Australia, he also took a tour around the South Pole. He could never come to an entrance place because everywhere he followed, over 50,000 miles, there was a wall of ice.
On January 17th, 1773, Captain James Cook became the first person to cross the Antarctic Circle. He then proceeded to circumnavigate Antarctica, which means he sailed completely around it. He came within 120 kilometres of the coast, but never once saw land. He saw lots of ice, but no land.
In the ball Earth model, Antarctica is an ice continent which covers the bottom of the ball from 78 degrees south latitude to 90 and is therefore not more than 12,000 miles in circumference. Many early explorers, including Captain Cook and James Clark Ross, however, in attempting Antarctic circumnavigation, took 3 to 4 years and clocked 50 to 60,000 miles around. The British ship Challenger also made an indirect but complete circumnavigation of Antarctica, traversing 69,000 miles. This is entirely inconsistent with the ball model.
Now, on the top, the North Pole is fixed. There's a North Star above it that is fixed. It never moves. So let's look at that for a moment. There's only 9,000 miles on the top, the ice around the North Pole. But there's over 50,000 miles of wall of ice around the south. That doesn't make sense. If the Earth is a globe, then it should be equally distributed. That the south down here and the north up here should have an equal distribution of ice. It could be a little bit, but 50,000 would mean that the ice would be halfway along the equator. 50,000 miles circumference of ice. So that's absolutely crazy. So you only have 9,000 miles of ice at the top and you have 50,000 at the bottom. So if it was round, it would be more like Tyson, the scientist, said that it would be like a pear shape. There's no way the Earth is a pear shape.
So you spin, when you spin pizza dough, it kind of flattens out. Yeah. Gets wider in the middle. And so Earth, throughout its life, even when it formed, it was spinning. And it got a little wider at the equator than it does at the poles. So it's not actually a sphere. It's oblate. And officially it's an oblate spheroid. That's what we call it. But not only that, It's slightly wider below the equator than above the equator.
A little chubbier.
A little chubbier.
Yeah.
Chubby's a good way. It's like pear-shaped. 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 Pear-shaped.
This is Antarctica. Google says it's about 5.5 million square miles. That's about the size of Greenland, Mexico, and the US combined. And Antarctica is the only continent that no humans are from. It has no indigenous people. So the fact that 99% of the world's population will never venture to the South Pole is the reason that this ice wall thing could easily be kept a secret. Now this is the UN logo. Notice the outside line, also shown here on their flag. This is the Flat Earth model. Okay, here's what we are told Antarctica looks like on the ball Earth, the South Pole, right? Now check this out. This is what the ice wall could look like from space. It's 360 degrees around all of the continents we know about, shaped just like Antarctica. Now overlay the UN logo over this view. Pretty interesting.
It is a flat round disc surrounded by a 50,000 mile perimeter of an ice wall. Now the other thing I want to show you today is to do a little experiment with this plane. Now, if we were to take a trip from Ecuador to Singapore, there are flights that will take you all over the North Pole and down to Singapore, right? So we've got a flight that's going to take us, we're going to have a flight that's going to take us from Ecuador in South America, following up towards the North Pole, going over the North Pole, and now we're going to come all the way down to Singapore. Now, there are two issues here with this particular flight that I'm going to show you now that it is impossible to do on a globe. The first one is that if it were true that we were on a globe and it was going like that, following the globe, then why did they put it on autopilot? You see, on autopilot, the plane is going to keep going straight. So it's going to go in outer space. It's not actually literally going to follow a curve. The pilots never change direction to follow a curve. They never do that. They always go straight. So the flight goes straight up in the air into the space. It doesn't follow a curve at all on autopilot. Now another thing that's very important, we've been told, just say hypothetically this is going at 500 miles per hour. Okay, so it's going at 500 miles per hour and it's two fixed points. The fixed point from Ecuador Airport leaving and the fixed point to Singapore. Okay, so they're two fixed points that we put in the computer of autopilot, and away we go start flying around to the next fixed point, which is here in Singapore. There's one problem. The globe is supposedly spinning at 1,000 miles per hour. So if it's a fixed point, okay, if it was a fixed point, then as we get out, we're not going to land in Singapore. Singapore now is over here. Because 1,000 miles per hour, if this is spinning at 1,000 miles per hour, then that point that they have located on the other side of the globe is now moved over, because we're saying this is 1,000 miles per hour, and this trajectory here we've got, because obviously we can allow for cutting through the middle of it, making a shortcut over, then we've eliminated a lot of speed in distance. But the problem is that it's not lining up, because this thing is constantly moving. So if the Earth was spinning all the time like this at 1,000 miles per hour, then this plane flying like that is not going to ever get to its correct direction unless the pilot takes it off autopilot and starts trying to hunt and follow where the movement of the Earth to try to make sure that it was going the right way. Because there's no way it's going to go direct like that. It's going to have to try to, dodge everything and go until it locates it. And then when it's lining up with the airport's still moving that way, so it's going to keep flying like that too.
The Earth spins once per day, which means that if you live at the equator, the surface of the Earth with you on it is moving around 1,000 miles per hour to the east, relative to the center of the Earth. Even at 45 degrees latitude, the Earth's surface is moving 700 miles per hour to the east, so it kind of seems like it should be faster for airplanes to fly west. I mean, their destination is literally spinning towards them. When we say the Earth is going 1,000 miles per hour to the east, that means that the ground, and airplanes on the ground, and even the air above the ground are all also moving 1,000 miles per hour to the east. For an airplane to get anywhere, it has to start moving relative to the ground and through the air at something like 100 or so miles per hour. So when it flies east, it's actually moving 1,000 plus 100 miles an hour to the east. And when it flies west, it's actually moving 1,000 minus 100 miles an hour to the east. Yes, to go west, you go east, just slower than the Earth is going east.
That's just totally ludicrous. So that's something to really think about, that if the Earth is spinning at 1,000 miles per hour, okay, rotating so like that, and then this is coming up at around 500 miles per hour, there's no way the two will line up from point to point that are fixed on a computer or GPS system to allow it to get to its ultimate destination. It won't do it, because this thing is moving, and while it's mobile, this thing is going to a fixed location. Okay, that is a very important point. There is no physics scientist out there that can explain that.
It seems like we haven't been changing our altitude at all. So I looked up what the average cruising altitude for airplanes is, and I found out it's about 40,000 feet. Okay. So I wanted to visualize this on the ball that we lived on, cruising at 40,000 feet in a straight line. So I came up with this graphic. 40,000 feet going horizontal, because in my reality, a straight line is a straight line, right? I don't know about other people's realities, where a straight line is supposedly curved. But in my reality, the plane gains altitude as it gets further and further away. I mean, not before long, this plane should be in space, right? I mean, where did the horizon go? So then I go back to my reality, and I find out that we just take off, hit 40,000 feet, and cruise over flat land like everyone experiences.
Welcome to Feed Your Mind, and I have another proof for you today, and it's about planes. So before planes take off, they calibrate their gyroscopes and they set it to level, and it's set level according to how it's sitting on the ground at the present moment before it takes off. So once it's calibrated to level and the plane takes off, so you'll notice the gyroscope will indicate that the plane is rising on an incline. And then once it gets to its desired height of air travel, the plane will level out, and that will be leveled out according to how it was calibrated, and then it will just cruise at its cruising altitude for however long they need to cruise for. So even if they're flying across the Atlantic Ocean or whatever, that gyroscope will not move from perfectly level status. So it doesn't matter where you're going or how long the trip is, that gyroscope remains perfectly level, does not deviate whatsoever, until the only time it's going to move is when you're headed back down. And then you'll notice the gyroscope finally move from that locked level position. So that's indicating that the plane is flying over a perfectly level, and how it locks things in. And what about the Coriolis effect, right? So there either is or there isn't a Coriolis effect, okay? So if the globe Earth is spinning from underneath us, why, when that plane is ready to land, why does that landing strip why don't they have to adjust for that landing strip? Because that landing strip stays put because the Earth is stationary. If there was Coriolis effect, that landing strip, they would have to adjust for that. When that plane is approaching where it's going to land, that strip is going to be moving from under them, according to Coriolis effect. But it doesn't adjust for that. It just lands. It lands on that landing strip without any adjustments whatsoever. So, yeah, gyroscopes prove that the Earth is flat. And there's testimony, too, about this. Pilots are coming out and confirming this. Air pilot instructors, air pilots themselves, they're all coming out now and confirming that the plane does not deviate from perfectly level status while in the air at cruising altitudes. And you might ask, why didn't these pilots come forward sooner? Well, the reason for that is simple. It's because nobody was thinking about flat Earth for the last 500 years. Yeah, you might have had a few here and there, but for the most part, nobody's been thinking about flat Earth since the time of Copernicus, when he invented the solar system, heliocentric, sun-worshipping Illuminati lie to worship the sun.
Now, the other thing that they can't explain is, if this is going across the whole world, why don't they adjust? You know, the way that they fly, they have this little needle that shows them the whole time that they're balanced level the whole time. So it's flying directly like that inside. That's how they see it. But how is it possible that it can fly on a curve but stay level? It can't. It absolutely can't. When you're up in those high altitudes that these planes get, then it would certainly need to go and curve around the Earth, because if not, it's going to start heading out into space. You see? So that is a good example of it cannot be a globe. Okay? As I said to you. Now, I'm going to show you another experiment. I'm just going to explain. With this particular plane, if this was to leave Ecuador, okay, and then it's going to fly all the way to Singapore from Ecuador, okay, so it's going to go over the North Pole. It's going to travel that way. Well, what happens if this is moving at 1,000 miles per hour, okay, by the time this reaches its destination, the Singapore is going to be somewhere else. You see what I mean? So the plane would need to fly, for example, if the Earth was rotating this way. Okay? So here we go. We're going in this way. We're going towards the fixed location, because they're both fixed locations for the autopilot to work. So as it's lifting off, going all the way around the Earth, following the curve of the Earth, and it reaches its destination, which is Singapore, which is a fixed position in autopilot. They make the thing so you can just rest and sleep for a while as it's flying over. Whatever they want to do, read a magazine, whatever. But the thing is that this flight is fixed, meaning it's just going to go in a straight line. Now the problem is, with that concept, if the Earth is going around like this, by the time it reaches its destination, Singapore is not going to be there, because it's spinning around there now. So Singapore is over there. So they have to make a dramatic turn to try and get there. But by the time they did that and go over there, Singapore's going to be over here. You see, so you would never be able to land a plane in any final destination, because the Earth is constant. Somehow the plane would have to keep following the rotation of the Earth, which is totally ludicrous. And as I was saying, if this is flying up and curving like that, why don't they do that in the actual autopilot? Why don't they make an adjustment for the curve? 8 inches for each mile, I understand. So there should have been an adjustment every mile, but it doesn't happen. The plane goes directly in line as if it's going in outer space, rather than as following any curve. So that is a very good example.
If you look up an image of the Earth and Moon, you're going to get a picture where they're quite close together. Something like that. But in reality, the Earth and Moon are about that far apart. That is the Earth and the Moon to scale. Taking the same concept, but for the solar system, every single picture of the solar system that we ever encounter is not to scale. If you put the orbits to scale on a piece of paper, the planets become microscopic and you won't be able to see them. There is literally not an image that adequately shows you what it actually looks like from out there.
my sun on top. That's my sun, okay? And I'm going to use this as an example that will say that the solar system, and that the sun is the center of the solar system, and that the earth, this is my little earth here, goes around the sun. Now here's a big problem with this concept. Now, so what I'm going to say is, see, this is, I'm going to use this as my sun. So I'm going to place it right here for now. And that's going to be the center of the universe. And I'm going to use this as my earth. And what I'm going to say now is I'm going to create a solar system, right? So this is going to be the center of the solar system, or center of the universe, or the galaxy, whatever you want to call it scientifically, the names they want to use. But I'm just going to say hypothetically that my sun is the center of the universe. And this earth, okay, is going around the sun. Now first, what we have to do is we have to take this 96 million miles away, over here, okay. Now at this point, it's now spinning. Okay, the earth is now spinning, right, at 1,000 miles per hour. Okay, so while I've got the Earth spinning at 1,000 miles per hour, now I have to go 666, strange figure that's been invented, but it's 666,000, million. Okay, it's 666,000 miles per hour. Okay, now let's do that. Let's go 666,000 miles per hour, because we've got to make 24 hours. We've got to make a whole full day and night to get back to this point. Okay? We've got to go all the way around the sun. That is 96 million miles away. And we've got to go at speeds of 666,000 miles per hour around that. Now, this is going to be crazy, but that's how it's going to be. Wow! Imagine. Ooh, that's how fast it's going. Much faster than that. I mean, I can't even physically do 666,000 miles per hour around the sun. At the same time, I've got to do, and remember, that's got to go 600, so to do a one-day cycle, we've got to go 666,000 miles per hour to get back to here. And at the same time, she's spinning like that. So the Earth is spinning at 1,000 miles per hour, and it's going 666,000 miles. Okay, the velocity like that. Now, what's wrong with that picture? Well, first of all, we would feel something. We'd have to feel some form of movement. And I'll tell you why. The reason why we would feel some movement is because we feel earthquakes. We feel a tremor. We feel just a tremor, right? So if we can feel a physical earthquake, when the movement of the Earth, when there's an earthquake, why cannot we feel the movement at 660,000 miles per hour, or that the Earth is moving at 1,000 miles per hour? We'd be so dizzy, it wouldn't be funny. Because I get dizzy. I don't know about you. But I remember I was standing in a building in Mexico. I was on the 5th floor, and it started rocking and rolling. That was back in 2002, I think it was. And it was rocking and rolling, and boy, I felt like I was going to faint or something. I was so dizzy. I felt the physical movement of the Earth as it was trembling. And it wasn't an earthquake. Imagine an earthquake. You're going to feel the aggression of an earthquake, right? But there's no feeling of any movement. No physics, nobody has ever been able to prove any form of movement. It's as still as can be. It is so still. It doesn't have any form of feeling of movement. That's just totally crazy. So that is another reason I'm saying that if we can feel earthquakes, we should definitely be able to feel the Earth spinning and going 660,000 miles per hour. We'd have to feel it. Now, another thing, back in my country in Australia, and it's not just Australia, but there's other countries too, where they actually have hailstorms that are a size like this size. Some are golf balls. Now, my question to you is, we can say it's condensation, that the vapor of the water is sucked up by the heat because heat rises, which automatically, literally defies gravity, which goes against the whole concept that the sea is stuck or pinned from the South Pole to the North Pole, that the water at the top here will never fall down into the south. Now that sounds pretty crazy. Think about it for a moment. If gravity was real true, then gravity would mean that the water would not pin at the north. It would all collapse and fall to the south. Because naturally, water goes down, right? So if it was all covered in water, the water would have to be level because water can never curve. Water never curves. I don't care who you talk to. Water never curves. It always stays fixed in a level. If that's not true, why do surveyors, when they map out the plains, why do people, engineers, when they make a bridge a very, very long bridge or the canal or anything, they take it from measurements of levels of water and they go straight across a train track. When they take a measurement of a train track, they keep on that line. They focus on a level. They don't follow a curve when they do it. They don't adjust their mathematics to be able to follow a curve. They keep to the sea level, and that's their main goal as surveying points continually. Okay, so that is a good point. Okay, now getting back now, I want to get back to the concept of ice. Now, if you get hail that's floating, suspended in the sky, okay, so we already know that the vapor of water, condensation, is floating up, right? It's defying gravity and it's floating up in the air to form clouds. But then those clouds are carrying like 660,000 elephants. Each elephant weighs a ton, right? So all that amount of water is just sitting there hovering above us, just floating in thin air. How is that possible? When everything that goes up must come down, right? So how is a weight of water able to suspend in the air? Now, let's not talk about water. Let's talk about snow and ice. Hailstorms this thick that go through like golf balls. They just go right through windshields. How do you explain that they have been sitting up there, forming, crystallizing to become like hard rocks up in the sky until it decides, that's it, I'm going to let you all go? How is that possible? How does nature decide, okay, I'm just going to let you go? You see, Mother Nature has to be alive. It can't be doing this just because, the elements say it's too heavy now, it's going to drop. Because we have very light rainfall, we have heavy rainfall, we have random rainfalls, we have random hailstones, so the little ones, and then other hailstorms are the big ones. There's no equality in any system here. There's no equation that can say, well, when it gets to this level, it drops. Because it randomly does all crazy stuff all the time. It can be full of snow, or it can be full of ice blocks, it can be full of water, or it can be full of just little mist, dew. But there's no reason to say, well, at this level it's going to rain, or at this level it's going to, we know when there's black. Another example I want to show today is what happens when you dive into water and you go very deep. Well, the pressure of the water is so heavy and compounds so much that if you go too deep, you'll have to go into a decompression chamber. So as the water is deeper and deeper and deeper, the pressure of that water is so strong, it will crush us the further deeper we go. Now, with that type of force, with that type of pressure and energy that's forcing that water to pin down, there's no way it could do that on a curve, because that pressure would just push all the water straight down to the South Pole. Now, another issue is if we were to believe that it's gravity that's keeping it down and keeping it in a curve, which is totally ludicrous because water doesn't curve. But if we were to believe this fantasy, then another big problem we have with this particular concept, but the concept that if the water is pinned down by gravity, then why can a feather float up and defy gravity? I mean, why can we even walk? I mean, we should be pinned. I mean, literally, with the weight of the compression of water that's pinning to the curb that would crush us instantly because there's so much weight and so much pressure going in on the water in the sea and the ocean, then that same concept should be applying to us as well. We should be pinned that we could not even lift a leg off the ground because of gravity. Now, supposedly on the moon there's no gravity, so they can jump with the cables on either side, pulling them up as well. But my point is that if gravity is the concept here, then gravity would pin us down. We'd be stuck to the earth. We wouldn't be able to get off. and walk. Couldn't get out of our bed. We'd be stuck. It'd be like sucked in like a magnet, and there would be no way to get out of it. So that whole concept doesn't make any sense whatsoever. So as I said, with that in mind, we have, I remember in one of the Terminator movies with Arnold Schwarzenegger, the Mercury robot that was after him gets stuck on a magnetic force that's spinning around. It just takes all her and wraps her. Well, that's what gravity should do to us on the Earth. It should pin us on and
it's working. Come on.